In today's video, I'm going to be talking about how we can prove the inverse of trigonometric functions. So today I'm going to be talking about sine inverse specifically, and basically how do we differentiate sine inverse of x. In this case, just looking at it, you cannot differentiate just by using the normal derivative processes that you've been using before. So basically, from here, since we don't know what sine inverse of x is, but we do know what the derivative of the sine of something is. So in this case, we'll just have to basically put sine on both sides, and sine inverse will cancel each other, meaning we're going to end up with sine of y equal x. And then from here, basically, since we know what the derivative of sine of y is, we'll just go ahead and differentiate that. And basically using implicit differentiation, if we do the derivative with respect to x of sine y on this side equal the derivative with respect to x of x on this side, we're going to end up with deriving sine y gives us cosine y dy dx equals deriving x just gives us 1. And then from here, since we want dy dx to stand by itself on one side of the equal sign, we're going to end up with dy dx equal 1 on cosine of y. All right, but then what do we do from here? Like, we know what dy dx is, but we still have a cosine of y, so that doesn't really add up. Like, it doesn't give us something proper. All right, so from here, all right, we'll have to include trigonometric identities, and the one we're going to use is sine squared of, in this case, it's going to be sine squared of y plus cosine squared of y equal 1. All right, and with this knowledge, we're going to basically solve this equation for cosine of y. And basically, we're going to send this sine squared of y to the other side, end up with cosine squared of y equals 1 minus sine squared of y. And then if we square root both sides, we're going to end up with cosine of y equals the square root of 1 minus sine squared of y. All of that square root, right? All right, and then how does this help us? Basically, from here, what we do is we substitute cosine of y here for the square root of 1 minus sine squared of y. All right, and you're going to see how that helps in a second. So once we do this, all right, all right, we know, or at least let me write it in this case so you guys might see this better. 1 minus sine of y, all that squared. We know sine of y is the same as x from here. All right, from here, from the beginning of the problem. All right, so if we substitute x in here, we're going to end up with dy dx is just equals to 1 over the square root of 1 minus x squared. All right, and that's basically your answer. And basically, a general form for this is just going to be, all right, if you're deriving with respect to x any inverse function that has to do with sine, and we're going to say in this case sine inverse of a, right? Basically, your answer is going to be a prime derivative of a divided by the square root of 1 minus a squared. That's it. Thank you.